The universe is filled with wonders, vast galaxies, swirling nebulas, and the intricate dance of celestial objects captivate our imagination. But there's another marvel unfolding right here on Earth, the rise of artificial intelligence. It's a story that began not in the depths of space, but in the minds of mathematicians and scientists. These pioneers dared to ask a profound question: can we create machines that think? This question ignited a quest, a journey to replicate the extraordinary capabilities of the human mind. Early attempts at AI might seem rudimentary today. However, they were crucial first steps. Imagine trying to teach a machine to play chess. You wouldn't start with complex strategies. You'd begin with the basics, the fundamental rules that govern the game. That's precisely what the pioneers of AI did. They focused on symbolic logic and rule-based systems, establishing the foundation for artificial intelligence. These early systems were like diligent students, meticulously following instructions and applying predefined rules. They excelled in structured environments where problems could be solved through logical deductions, but the real world is messy and unpredictable. It's filled with nuances that are difficult to capture in rigid rules. To truly mimic human intelligence, AI needed to embrace the uncertainties of life. Imagine a world where machines could solve complex equations, play checkers with remarkable skill, and even hold conversations. This was the promise of symbolic AI, a realm where logic reigned supreme. It was a time of immense excitement and boundless optimism. Researchers believed that by encoding human knowledge into a series of rules, they could create machines capable of reasoning and problem-solving. Symbolic AI thrived on precision. Every rule, every instruction was meticulously crafted to guide the machine towards the desired outcome. It was like building a house of logic, brick by logical brick. And for a while, it seemed as though this approach could unlock the secrets of true artificial intelligence. However, cracks soon began to appear in this seemingly impenetrable facade. The real world, with its infinite complexities and ambiguities, proved to be a formidable opponent for purely logic-based systems. Teaching a machine to recognize a cat, for example, became an insurmountable challenge. How do you define a cat in a set of rules that encompass all its variations? The limitations of symbolic AI became painfully clear. The quest for true intelligence required a new approach, one that could handle the uncertainties and complexities of the real world. The cosmos, in all its grandeur, is a testament to the power of probability. From the formation of stars to the evolution of life, chance encounters and random events have shaped the universe we know. And it was this realization that uncertainty is an inherent part of existence that led to a paradigm shift in the field of artificial intelligence. Enter the era of probabilistic models. Instead of relying solely on rigid rules, probabilistic AI embraced the power of statistics and probability theory. Machines could now deal with incomplete information, weigh different possibilities, and make decisions based on the likelihood of outcomes. This new approach opened up a world of possibilities, allowing AI to tackle problems that had previously seemed insurmountable. Imagine a medical diagnosis system. With probabilistic AI, the system could analyze a patient's symptoms, medical history, and other relevant data to provide probabilities for different conditions. It wouldn't claim absolute certainty, but would offer a range of possibilities, assisting doctors in making more informed decisions. This ability to deal with uncertainty marked a significant leap forward in the evolution of AI. It paved the way for systems that could learn from data, adapt to new situations, and make predictions with increasing accuracy. The neural revolution mimicking the mind. The human brain, a 3-pound universe within our skulls, is perhaps the most complex structure known to humankind. It's a network of billions of neurons, interconnected in ways that we're only beginning to comprehend. And it was this biological marvel that inspired a new wave of AI research neural networks. These artificial networks, loosely modeled after the structure of the brain, promised to revolutionize the field. Unlike symbolic AI's rigid rules, neural networks learn from data. They consist of interconnected nodes or artificial neurons that process and transmit information. By adjusting the strength of connections between these nodes, the network learns to recognize patterns, make predictions, and even generate creative content. Imagine teaching a neural network to recognize handwritten digits, You would feed it thousands of examples, each labeled with the correct digit. The network would analyze these examples, adjusting its internal connections to minimize errors and improve its accuracy over time. This ability to learn from data is what sets neural networks apart. They can be trained on vast datasets, enabling them to perform tasks that were once considered the exclusive domain of human intelligence. AIs Senses awaken, seeing, hearing, and understanding. We humans experience the world through our senses. We see the vibrant colors of a sunset, hear the soothing sounds of nature, and understand the nuances of language. And now, thanks to breakthroughs in AI, machines are developing their own senses. Speech recognition, natural language processing, and computer vision are no longer futuristic dreams, but powerful tools shaping our world. Speech recognition systems can now understand our spoken words with remarkable accuracy. Virtual assistants like Siri and Alexa respond to our commands, transcribe our voice memos, and even translate languages in real time. This technology is breaking down communication barriers, making information more accessible to people around the globe. Natural language processing, on the other hand, enables machines to understand the complexities of human language. AI-powered chatbots provide customer support, language translation tools break down communication barriers, and sentiment analysis algorithms gauge public opinion by analyzing social media posts. The ability to comprehend and process language is fundamental to human intelligence, and AI is rapidly catching up. Beyond imagination, the emergence of creative AI. Creativity, once considered a uniquely human trait, is now within the realm of artificial intelligence. Generative AI, a new frontier in the field, empowers machines to create original content, from stunning artwork and music to compelling stories and even scientific discoveries. This is not mere mimicry, it's AI venturing into the realm of imagination. Imagine an AI system trained on a vast data set of paintings by renowned artists. By analyzing the patterns, brushstrokes, and use of color, the AI can generate entirely new artworks that capture the essence of the masters while adding its own unique flair. This is not to say that AI will replace human artists. Rather, it will serve as a powerful tool, augmenting their creativity and pushing the boundaries of artistic expression. Generative AI is also making waves in the world of music. AI algorithms can now compose original pieces in various styles, from classical symphonies to catchy pop tunes. They can even analyze a person's listening habits and generate personalized soundtracks tailored to their individual tastes. The possibilities are endless, with AI poised to revolutionize not just how we create music, but also how we experience it. Expanding Horizons plugins as AI's toolkit. In the vast expanse of the cosmos, stars often exist in clusters bound together by gravity's invisible hand. Similarly, in the realm of AI, individual systems are becoming increasingly interconnected, forming a constellation of intelligent agents capable of collaborating and achieving complex goals. Plugins, the celestial bridges in this AI ecosystem, allow these systems to tap into external resources, expanding their capabilities far beyond their initial design. Think of a language model like ChatGPT. On its own, it's a powerful tool for generating human-like text. But with the right plugins, it can transform into a multifaceted assistant. Need to book a flight? There's a plugin for that. Want to order groceries online? There's a plugin for that too. These plugins act as gateways to a universe of information and services, empowering AI systems to perform tasks they were never explicitly programmed to do. This interconnectivity is crucial for the future of AI. As individual systems become more specialized, their ability to collaborate and share information will be paramount. Plugins facilitate this collaboration, creating a symbiotic relationship where the whole becomes greater than the sum of its parts. Just as the stars in a cluster work together to create breathtaking celestial displays, so too will interconnected AI systems shape the technological landscape of tomorrow.